So this is part 2 of decision trees in machine learning models. So we're considering two features, and they are displayed in a two-dimensional plane. So we're displaying the first column, the first feature, with the chronological age of the pet or animal. On the horizontal axis, there is x1, and then the vertical axis x2 is displaying the second feature, which is basically the residence time in units of months. So because the categorical variable has been encoded already into either zeros or ones, then that is displayed here in terms of a shape and a color. So here we see the data points represented with circles in color red. That represents the value of 0 for in the target or this feature of outcome of adoption, representing there was no adoption, and the value, the value of 1 is represented with the color black and the shape of a diamond, right? So so this encoding that already took place and is encoded with binary. This is a binary classification with two classes. So one class is represented with the color red in filling circles, another class is represented with color black, with the color black with diamonds. And that's the display we have in this two-dimensional. So by performing a machine learning model, the visualization of this model is to recognize regions in this two-dimensional space. Once the model would do its job, it would come back with predictions as to how the space is segregated into regions containing data points, and the predictions is as to whether those regions contain data points representing one of the two classes, the class that has a value of 0 or the class that has a value of 1. So we take a look at the root node here. This root node has a condition relative to, when we say, a threshold value, even though the condition is an inequality, is a less than or equal to, but the value that we may consider a threshold is the value of 5. So x2 is represented in the vertical axis, and that value, as the values on the vertical axis have a scale from 0 to 10, then that value of the threshold is right in the middle. And so we may use that value, that threshold value, to split the vertical axis, and therefore we would consider this is denoted here with a dotted line or dash or dotted line, and then that would split the two-dimensional plane basically in two sub-regions. Now, one observation is that these two sub-regions are such that the upper portion, which is displayed here with a shade in gray, that portion contains points of the same categorical value. So all the points above the value of 5 in the vertical axis, they are all diamonds of color black, and that means that they are encoding the class that has the one of the two possible values. It has the value of 1, meaning that that was a successful adoption. But below that threshold value of 5, we have a region that's shaded with a color pink, and most of those points are of the same color. However, they are of this color red, which encode the categorical value of 0. There is one point that is not of that color, but most of those points in the pink subregion are of the same, are kind of encoding the same class. So we're gonna address a couple of things now, which the first is the decision of how to set a node to be a root node. And to do that, we need to select a feature and determine a condition to split the values on that column. And to find a good split condition, we would select a feature and select the value that best separates the data points in that column or feature. So for example, and for the feature we're calling x2, the column we're calling x2, the value of 5 basically splits the data almost evenly into two groups. And well, this is what we have noted already, that above the dotted or dashed line, we could actually consider that group of data points to be completely pure. They all belong to the same encoding of 1, while the other one is almost just as pure. There's only one confuse that remember that these machine learning algorithms sometimes they make erroneous predictions or make mistakes, and there's only one of such things in the pink region. So the idea then is that one will continue to split data points with more questions meaning conditions, until you correctly classify all data points. So the next step would be to work with the pink region, which has one data point that is not correctly classified. So that brings us to this split node, which has a condition, and that condition comes from taking a look at the horizontal axis and deciding that the value of basically deciding that maybe in the interval from 4 to 5 we may find a value that would serve as a threshold. In this case, it was decided that that threshold would happen at the value of basically the middle of the interval between 4 and 5 for x1. So 4.5 is used as a threshold, and then that serves to divide the pink region now into one region that is one subregion that is pure. All points contained to the left at 4.5 in the pink region are of the same encoding of having the class equal to 0, and then there are 2 points to the right. So on the left, pink is pure, just like the points above 5 in the original upper region, and now we have a region to the left of 4.5 with only 2 points. So next we decide on another condition to then subdivide that new subregion to the left at 4.5, and that condition is based on the values on the vertical axis. So we identify that here the value of 3 on the vertical axis may serve as yet another threshold that would split that region. Basically, we have subdivided the original plane into now 3 regions, and now we're that region that was defined by the value of 4.5 and on the horizontal axis is going to be subdivided into 2 subregions relative to this condition on x2. So above the value of 3, that's going to serve that's going to provide a subregion that contains only 1 point that is correctly classified, and then there is also another point below that which is also they're isolated and correctly classified. So one may state that the last condition is set relative to the feature x2, and one would choose a threshold value that would separate the remaining 2 data points into their classes. And so, as we just discussed, that threshold value, in this case, the value of 3, would work to do that. And at that point, at that stage or that step, all points are now correctly classified into subregions. So now that we have a machine learning model that has been trained, the goal would be how to make predictions. So how to predict y from x1 and x2, how to predict the target from 2 given features. So and that type of prediction could be, we could use the notation of f as what is the target, the output, given these inputs, the specific input of one value of x1, one value of x2. So that's kind of x1 at the value of 2, x2 at a value of 4. What would be the value of the target, assuming that y equals f, evaluated specific values of x, right? So in this case, we would find that with these inputs, so if x1 is 2 and x2 is 4, basically the second of these inputs would allow us to start with that root and go on this branch. 4 is strictly less than 5, and now the value of x1 is 2, which is strictly less than 4.5, and then we would predict that the value of y in this case would be equal to 0, which is what the information, it matches the information we have there. So the previous scenario was an illustration for making a prediction basically with the training data, right? That's what we use, the training data and the so-called train test split for evaluation on the performance in the model. But truly, once the model has been trained, we'd like to make predictions of considering points that are not in the data set, points that the model has not really seen. So here's an illustration for that. Suppose that the inputs are now, the feature x1 is 7.5 and the feature x2 is equal to 5. So with this value of x2, we would say, okay, x2 is less than 5, so we go along this branch. The value of x1 is 7.5, which is not smaller than 4.5, so we'll go along this side. And then we take a look again at the value of x2, which is 5, and it's, is it bigger than 3? And 5 is bigger than 3, so we would go along this branch here, and then we would conclude that the value of the categorical variable is equal to 0. So in this case, the prediction is a value of 0. We would say that this is no longer a question here. The value of f is equal to 0.